Hello and welcome. So today we are going to learn about how we can add grooms to our Apex characters. And grooms can be of any type, either hair or feather. And you also need Apex rigged characters on which you want to add the groom onto. And in this tutorial we will use Electra as our test geometry on which we will add the groom. And you will find the groom which I made in the description as a HIP project file. And please subscribe because that helps me a lot. So let's jump to Houdini, and over here I have the feather template and the feather groom, and also a standard hair groom. As you can see, this is the hair groom, this is the feather groom, this is the feather groom, and they are groomed on top of the Electra test geometry. So let's now drop down a geometry node, groomed character, and jump inside, drop down a test geometry Electra, and we'll have this, and set the output to Apex character, and then drop down a object merge, which will be inputting our grooms and grooms, and this to let's use the hair groom first. So this is our groom, the hair groom, which doesn't look very nice, but I just made this for this tutorial. So to add it to our Electra character, the Apex character, we want to use the Apex add groom node. The first input is for the character, and the second is for the groom. And then you have to set the display flag. And now just by doing this, you can now go to the pose mode, and you will see that our hairs, the hair groom is constant to our head. And I'll show you how that is happening. So over here you have options to output curves and output surfaces. We don't need surfaces right now because this is not a feather, but if it is a feather, then we'll need to output surfaces, or we can just keep the curves, but we can use surfaces too. Anyways, and you can also curl the sort curves by setting it to curl and then moving the length threshold slider. And over here you have options for the joints, the control joints, which we will be making right now. And the name prefix will be the prefix of those joints. So just set it to here right now because we are not doing it for feathers. And the skin vector attribute, which is currently set out to N, which stands for normals, is for orienting the control joints to the normal of the test geometry. I mean the character we have. Or you can use any other attribute over here, like a tangent attribute. Now you can click on this plus icon for the control group's multi-palm, and now you get a lot of options. And first we have to select the hair strand on which we want to orient the joints, the control joints. So let's select one of them, just like this, and now you have these joints, and now you can rotate them easily, and you have the hairs affected by that. You can also turn on this orient to skin vector attribute, which will obviously use this skin vector attribute you provided over here, and now you have better orientation for them, as you can see, joints. And you can also control the width of the control joints, control boxes, as you can see. And you can also limit influence distance either by a mask or these parameters over here. And the mask attribute should be a primitive attribute on the Groom itself, and you can use this limit influence distance also. So let's set the maximum distance to something like this and core distance to something like this. And now if you rotate this, as you can see, we don't have these the other hairs being rotated because we limited the influence distance, but we don't want to do that. And you can also add more joints, but that's not how you do it for grooms. So you don't just input all of the grooms you have, like the one on the one for the head hairs and the one for the, what do you call it, cheek hairs. You have them separately, and then you add other 8 groom chains, other 8 groom nodes to handle them. You don't just do it on single 8 groom node. And over here, the reason behind having this number-based control groups is because you can add left or right controls for it. So we can select another stand, here stand. So let's select this, or let's just select one from here. Let's select this one, and we also have to add a suffix to make it visible, and we can also orient this one to the skin vector attribute we provided over here. And if you rotate now, as you can see, we have them both working. And you can also add a suffix of left over here, but we don't have left or right controls right now. I just did it for testing, so we don't need this extra joint anymore. And over here on the rig parameters, you have option to set up the rig. If you uncheck it, the rig won't be set it up and it just won't work. And you also have the option for the node prefix on the rig. So the nodes which will be added to the rig for this add groom node, which will have they will have this prefix of groom. And this skin normal attribute and skin tangent attribute will be used to constrain these controls to the head. And I can actually show you the rig. So let's do a impact folder, and we can extract the rig. Oops, rig. And now we have the rig, and we can do a git graph, and we can go to a Apex Network View tab. You can open that using this plus icon and new pen tab type, animation, maybe animation, and Apex Network View. And over here, as you can see, we have these nodes of the transform objects for the joints. As you can see here, we also have the here prefix for them, which we set it up over here. So as you can see, over here, as you can see, name prefix. And we have over here a prim constraint node, which will constrain the joints to the head. And as you can see, if you see the parameters, we have the tangent U and the normal, which we set up over here, being fed up over here. And then that goes to this groom control root joint, which is not visible because we don't have the transforms exported. But we do have that for this, as you can see. it is promoted outside, and this just works for creating a parent for this here joint. And then we transform the groom based on it, and we output that. And now we can do, and now we can add it to a scene. So apex scene add character, and this is the character and not a scene. Can rename it to Electra, and then we can do a scene animate to animate it, and we can obviously move this. And then to get it out of this Apex packed folders, you want to use a scene invoke node, and then you have to click on output all character shapes. And if you just want to output the Groom, then you can remove this base.shape, and then we have to unpack it with 2 iterations to get the actual geometry. And as you can see, we have the Groom deformed as we animated it. And now we will see that how we can do the same thing for feather grooms. So now let's input the feather groom, and we can go to the add groom again. And before we do that, we want to resample that. So do a feather resample so that it is fast enough for the pose mode. And then we can resample the shaft base and set the segments to something like 4, and we can also resample the shaft to segments of 75 maybe. Yeah, that's fine and fast enough. Now we can go to the edge groom node, and you just have the curves right now. We want to output the surfaces too, and now it will create the surfaces based on the feather we provide over here. And we can remove these control groups right now, and we can change the name prefix to feather now because it is feather. And now we can add a control joints for it. Let's select one of these feathers. So let's select this one, and now you will get the control joints oriented to that feather, as you can see. And everything just works the same, and we want to turn on the orient to skin vector attribute to have a better orientation of the joints. And now if you move this, as you can see, you can control the feathers. Let's see. And it is also concentrated correctly to our head. And now we can just animate it again, and you'll have it working. And now we'll see that how we can get the feather groom back again to work with, to render it. So let's delete these scene invoke nodes, create a fresh one, scene invoke, output all character shapes. And now there are 2 methods to get our feathers back again. First method is to use the curves, and the second method is to use the surface. So let's not output the Electra base.shape, and we only want the curves to, so only keep the groom.shape output. And now we have these curves. Now we have to unpack it with 2 iterations. And now you have the attributes. We also have the bar orient on it, but we don't have the positions of the bars or anything like that. So we have to do it on our own. So drop down a feather interpolate template interpolate node, and the first input of feathers would be this, and we also need to input the templates, the feather templates we have. We'll do a object merge and input the feather templates, which is in the feathers geometry folder. And now we have this template coming in, and now what we have to do is set the lookup method to match by name attribute, and now it will look for the template name attribute which we already have on our these curves. As you can see, we have a template name attribute, primitive attribute over here, and now we get it. So this is our feather, and now you can just render it. And there is another way of doing it, which is by using the surface output of our scene invoke. So let's click the output all character shapes again and only keep the Groom surfaces .shp. And now we have this. And to get the feathers move according to this, we want to use a feather deform mode. And the geometry to deform should be this, the input Groom we have over here. We can create a pin over here so that it is organized fully. And we can click Shift plus S to change the wiring style. And now we want to unpack the surface before it was transformed. So before we apply the scene animator to it, so drop down the unpack folder and set it to, click on this icon and select the Groom surfaces.shape, accept, and then this will be our rest deformers, and this Groom surfaces shape scene invoke will be our last input, animated deform. And then you have to set the deformer type to surfaces, and we forgot to unpack it with 2 iterations. That's why it is not working. So unpack it with 2 iterations so that it is now a unpacked geometry, and this will be our animated deformers, and then it should work properly. So as you can see, this is our invoked shapes, and this is our feather which is correctly deformed. So you can use any of these methods to deform it. I usually use the template interpolate method on the curves, on the Groom curves, but you can also use the surfaces. So now you just have to drop down a null and connect it, and this will be our out Groom deform, and you can just render it, or you can invoke all the characters, and you can also do a scene invoke for the Electra. So let's output all character shapes, and we only want to keep the base.shape, and we can merge that over here after unpacking it with 2 iterations. And now we have that, and now you can render it. So this is it for this video. Thanks for watching. Like and subscribe. Bye bye.